So what are these stress razors? Generally, I suppose the best idea to understand the stress razors is by the sheet of paper. We get some sheet of paper and we try to break it, yes? If you would just grab it here and here, here and here, with our hands, we would need to apply quite a bit of force in order to break it, yes? However, now let's imagine that we make some modification. We get some small tear inside here. And we do the same. What would happen? It would break without any problem. Although, look at this. The generated strength of the paper is not changed much. Yes, we just took a little bit of material. The geometric properties, theoretically speaking, should not change much. The material properties did not change at all. However, this point became a stress razor. How to understand the stress razors? Generally, if you would get the forces that are getting, yes, we have tensile forces, yes, and they are getting in this direction. So these are imaginary tensile forces lines that are getting through this. But here we are also getting this line, but it cannot get through. So where it would go? Here. Here it would also this line and would go here. So we would have in this spot high concentration of the force. This is a point of increased stress because it would be accumulated. Yes. The bigger would be the cut, the bigger would be a stress that is on this very tip. Yes. So it will all lead to situation that we would have really big problem with sustaining this stress. That the material in this very spot would have very big problem with sustaining this stress. And when it would tear a bit, the situation would get worse and worse. And this is the idea of stress razor. Okay, what type of the fractures we have? Generally, we have different types of fractures depending on what forces are applied. So and you need also to remember that the bones are strong in compression, but weak in tension and shear stress. So first of all, let's apply to the bone the compressive stress. What would happen? Generally, usually in case of the compressive stress, you would have the oblique fracture. Why oblique? Because this is a plane of the highest shear stress. How to imagine this? Generally, if you have a rubber and you will compress it, yes, the particles from the middle would get to the sides, yes, because it would get thicker in the center. The particles above would get to the opposite side, yes. Maybe not exactly like that, but wait a moment. Here. So let's get this line. Like this. So the particles below this line gets in this direction, yes? The particle above this line gets in this direction because they are compressed from the top, yes? They are compressed from the top, so they get here. Those particles get here. So what we would have? We would have the line in which the particles are traveling into different directions. It's like a scissoring motion, like scissors, yes? And this is a shear stress. This is very hard to sustain by any structure, including the bone. Why it's not fracturing in this plane? Because the bones are just strong in compression. This is just the simple compressive stress, and the bone can sustain really high compressive stresses because before it would fail. Okay. So this is the compressive and simple oblique fracture. We also have something a bit different. In case of the bending with the bending plus compression, yes. So of course I'm exaggerating far more, but we try to bend the bone. Yes, what is happening? On this, from the simple beam theory, then here we have the high tensile stress, here we have the high compressive stress. Yes, so the bone is weak in tension, so it would start to fracture here. But if we have also additionally compressive stress applied, here you would have a high compressive stress. You know already the bone is strong in compression, but this compression leads also to some shear stress. Yes, and it may lead to the butterfly fracture because we have the combined this tensile stress and shear stress lines, and it leads to this butterfly fracture. We also can have the compression with rotation, yes, and this will obviously twist the lines of the forces, and it will lead to the spiral fracture. Simple like that.